Okay, students. So take out your calculator and I want you to try to draw a graph of y equals L and X. Y equals L and X. Please draw the graph y equals L and X and y equals log X. Please draw these two graphs on the same screen. Yeah, the other one as well. Y equals log 10. Students, you need to remember its property. Firstly, can you see it passes through the point 0,1? No, it's not 0,1. Sorry, guys. It's 1,0. Please correct it. Please correct it. 1,0, 1,0. And also has the y-axis as vertical asymptote. Asymptote means when x goes to very, very close to 0, the y goes to infinite, negative infinity. Can you see that? As x goes to 0, y value goes to negative infinity, negative infinity. It means that this graph never touches the y-axis. Do you understand? That's why we call this line as asymptote, asymptote. What is the equation of y-axis? X equals 0 or y equals 0? Equation of y-axis. X equals 0, x equals 0. And when you draw this graph, y equals log x, log x. I am going to draw one graph in this way. Okay. So please tell me which one is red one, the first one or the second one? I draw two graphs, right? The second one is the red one or the first one is the red one? Please check your calculator and tell me. The first one or the second? Please look at your calculator. Second one is red one. First one is the red one, okay? This one is this one. And the second one is the blue one. So do you remember what base it has, ln(x)? What's its base? E. What's its base, student? 10. Which base is bigger? 10. So as you can see, as the base is bigger, and then the graph is lower. Can you see that? Okay. Please write down larger base, lower graph. Okay, students. So Jason Tao, please read question number 1.
Y equals to ln x and y equals to 2 over x.
Okay, students, please draw a graph of these two on your calculator.
Correct.
Guys, this graph is shown inverse y is inversely proportional to, it's inversely proportional to x. Can you see that? Okay, so the graph is shown in this way. So how many solution it has of this one? Okay, so x, ln x equals 2. It means that you can divide it by x divided by x both sides. And then you can make this as ln x equals 2 over x. It means that the solution of this equation is actually the simultaneous equation solution of y equals ln x and y equals 2 over x. Do you understand? So you need to find the intersection point of these two graphs to find the number of solution of this equation, which is how many solution it has? 1. And Ferdinand, please read the question number 2.
On the same diagram, sketch the graph of y equals then x and y equals then bracket x minus 2. They will all intercept with the coordinate axis.
Okay, students, please, by using your calculator, draw these two graphs. Okay, students, y equals ln x is converted to, let's say, y equals ln x minus 2. Can you recognize what transformation it is? Stretch, transformation, translation, reflection. What is it? Translation. Thank you so much. Translation by the vector 2, 0. Very good. Because students, the only change variable is x. So x minus 2 to x and y is just y. That's why the vector is 2 and 0. Please bring back your memory if y equals fx is transformed to y equals, let's say, fx minus n plus n. It means that y minus n equals fx minus n. It means that you put x minus n to x and you substitute y minus n to y. It is translation represent mn as its vector, okay? Please remember it. So basically it means that from the ln x graph, which is in this shape, you can translate it on the x-axis or y-axis. Translate it to x-axis. How many units? 2 units. So since this one is 1, 0, it's gonna be translated 2 units, which is
3-0.
3-0, very good, 3-0. And then guys, this asymptote as well. This asymptote, which is x equals 0, it's gonna be moved to 2 units as well. Do you understand? Students, please answer me, do you understand? So the graph is gonna be shown in this way. So therefore, the asymptote of this graph can be changed as x equals 2 in this case. Okay. And then Jason, please read question number 3.
Let K be a positive constant. Use a graphical method to prove that the equation Kx plus ln x equals to 0 has exactly one solution.
Okay, students. So firstly, you need to use graphical method. It means that you need to separate this equation first, and then you need to make a simultaneous equation from this equation. How do you separate this graph? How do you separate it? Just move this one to the right side, and it's gonna be ln x equals negative kx. Do you understand? So from here, how can you make a simultaneous equations? Y equals ln x and y equals negative kx. Do you understand? So the intersect points of this simultaneous equation, so their graph, it represents the solution of this equation. Students, do you understand? Okay, then let's just draw this graph. The first one, ln x graph. I want you to remember the shape of this graph, okay? This is y equals ln x. And then y equals kx. What's the shape of this graph, students? Yeah. And firstly, line or curve?
Line.
Line, straight line graph passes through the
Origin.
origin, passes through the origin because y-intercept is 0. Can you identify it? Its y-intercept is 0 because there is no c. Okay, so passes through the origin. And then since k is positive value, negative k means negative value. So its gradient is negative. So it should go down or up? Down. Do you understand? So even though we don't know what k value means, but still we can identify how many solution it has. How many solution it has? Go. One solution. Very good.
Interesting at time 0.
Okay. So y equals negative kx. You can identify if you put 0 to x, then the value of y is 0 as well, right? So it means that it passes through the origin. Or the basic form of line graph is y equals mx plus c. There is no c here. It means that the value of c is 0. So y-intercept is 0. So it means that it should pass through the origin. Understand? Okay, let's move to the next question. Okay, students, y equals ln x can be transformed. It's just either translation or stretch, okay? So let's identify this one as stretch first. Y equals ln x 2, y equals ln 3x. It means that if we define this function as y equals fx, then we can write y equals ln 3x as fn
And breaks.
3x. Do you understand? So it means that you substitute 3x to x, y, just y. So it is stretch. Stretch to the horizontal line or vertical line? X-axis or y-axis? X-axis. Scale factor. What is scale factor, students? 1/3. Very good. 1/3. Okay, 1/3. This is an interpretation by stretch, but also it can be interpreted as translation as well, because I'm going to erase it for translation. Y equals ln x 2, y equals ln 3x. Students, 3 and x, what's the operation between 3 and x? Multiplication, right? Multiplication, so that you can separate it by using 2 logs, which is ln 3 plus ln x. So ln x plus ln 3. So if I write down it as y equals fx, you can express this one as y equals fx plus ln 3, or y minus ln 3 equals fx. So x is just x. You substitute y minus ln 3 as 2y. Do you understand? So it's a translation by the factor 0 and ln 3. Okay, ln 3. Do you understand? Okay, students, I'm going to skip the question number 5. I'm going to leave it as your homework. Let's solve question number 6. Ethan, please read question number 6.
Log 10 x equals k ln x.
A,
By raising 10 to the power of both sides show that k equals 1 over L.
Okay, by raising 10 to the power of both sides. So 10 log 10x equals 10 to the power of k ln x. Okay? And students, do you remember a to the power of log bc equals c to the power of log ba? Okay? Please remember these laws of logarithm. So you can switch these two. You can switch these two. Do you understand? So it means that you can switch these two. You can switch these two. Okay? So after switching, we can write it as x to the power of log 10 and 10, and then x to the power of k ln 10. Students, do you understand? And then since the base is the same, so you can write down this one is same as this one. Okay? So it means that what is log 10, 10? The base and the value is the same, 1. 1 equals k ln 10. It means that the value of k is 1 over ln 10. So basically by following the instruction, and after using the laws of logarithm, you can find the value of k, right? Okay. And then B. Hayden, please read question B.
Describe fully the transformation that transforms the graph of y equal ln x to the graph of y equal log 10x.
So just write down y equals ln x, guys, and then make an arrow because it's transformed to y equals log 10x. Firstly, you need to write down by using arrow to show that it's a transformation. Do you understand? And secondly, always this type of question, you need to use the result, what you got from A, which is you can write log 10x as k ln x. What is k? Thank you. 1 over ln 10 and ln x. Do you understand? Students, do you understand? So it means that ln 10 equals ln 10 times y equals ln x. Let's figure out what transformation it is. If we define it as y equals fx, we can write it as y times ln 10 equals fx. Okay? So you can substitute x, just x as it is, but y times ln 10. What's this? Translation, stretch, or reflection? Stretch. So it changes only y variable. It means the vertical or horizontal. Guys, only y variable has been changed so that it's vertical stretch, okay? It's vertical stretch. What is scale factor? Scale factor. 1 over 10 or 1 over ln 10 or ln 10?
1 over.
1 over ln 10. Always use the reciprocal, okay? Use the reciprocal. I'm going to write it down here again. Even though I don't have time, but please remember the stretch, the transformation. So for example, y equals fx. Stretch, horizontal stretch. Scale factor k, it means that you need to write down 1 over k to 1 over kx to x.
Are we doing evolution?
B. Wait for a sec. 1 over k. If the scale factor k, and then you need to write down 1 over kx. Okay? So y equals f 1 over kx in this case. If there is y equals fx, vertical stretch, scale factor k, it means that you need to substitute 1 over ky to y. So 1 over ky equals fx. Therefore, you can write it as y equals k fx. So you may think that y X is, if the scale factor of X is K, but in this case, 1/K, but Y is just write it as it is, but actually it's the same, the reciprocal. We just move 1/K to the right side to make it look as K. Does it make sense, students? Can you see the rules are the same?
No.
Angus, I'm very sorry.
Don't please, I beg you, please, just give me like 1 minute, please, just 1 minute, I beg.
How about I download it, okay?
1 minute. 1 minute.
Okay, so students, again, from Y equals ln X, the changed one is 1/ln 10.
Where are you?
Y times, wait for a sec, Y times ln 10 equals ln X. It means that you substitute Y times ln X. So the scale factor should be its reciprocal, which is 1/ln 10.
Why 1 U over here?
What is 1U?
And a B, it's like B dot B. Like 1 U over.
What is U? Where is U?
Oh, not one, this is covered, look rectangular one, sorry.
No worries, it's okay. Okay, students, we are gonna move to section 3. Section 3. It's gonna be, this is very, very important section. So Andrew, please read the topic of section 3.
Exponential functions and mathematical modeling.
You
We know
know,
that the gradient of an exponential function y equals e to the power kx is proportional to the y value.
wait for a sec. It means that, guys, what is the gradient of this function? K times e to the power of kx. So it means that k times, since y equals e to the power of kx, we can write it as k times because this value is y, right? K times y. Do you understand? So if I write down, so gradient is defined as k times y. Do you understand? It means that gradient is proportional to y. Okay? This is what it means. Yeah.
I understand the gradient is like proportional to y because of like y equals e to the power of kx.
Yes.
But I don't understand how you find like ky.
What? Look, no, watch this. Because ekx is y.
Yeah, this one is y, right? What's the? Yeah, that's why ky. This one. Okay. So Andrew, thank you so much. Please keep reading it. This means
This means that if a quantity grows or decays exponentially, then its rate of change is proportional to the quantity itself.
so rate of change. I told you rate of change is gradient, okay? It's gradient. Gradient is proportional to quantity itself means y itself, okay? Y itself. Actually, it makes sense because, guys, let's imagine that there are two regions, region A and region B. In region A, the number of population is 1,000. In region B, the number of population is 1,000,000. Let's imagine it. And then the number of growth, the rapidity, the speed of number of population growth, which region is bigger? B. As the population is bigger, and then the number of children is more and more, right? That's why the rate of change is proportional to quantity itself. So the rate of change is way bigger from in region B than in region A. So, Andrea, please read these thoughts.
A population increased at a rate proportional to its size. The rate of a chemical reaction is proportional to the amount of reactants. The rate of radioactive decay is proportional to the amount of the substance remaining. The value of an investment that is subject to compound interest increases exponentially.
So all these change can be modeling by using exponential functions. So for example, let's see example 8.4. Hayden, please read this question. Savannah, please read this question.
Number of hours.
Okay, students. So for example, let's find the initial number of bacteria. Okay, initial number of bacteria. So initial number of bacteria means the number of bacteria at 80. So it means that when t equals 0, because we start to calculate the time from 8. So when t equals 0, what is 2 to the power of 0, students? 1. Therefore, what is n when t equals 0? 1,000. Do you understand? 1,000. So when 8 a.m., the number of bacteria is 1,000. And then after an hour, because t is number of hours after 8 a.m. So 1 hour later, which is 9 a.m., the number of bacteria is going to be 1,000 times 2 to the power of 4 times 1, which is 1,000 times 2 to the power of 4. What is it? 16,000. Do you understand? And then 2 hours later, 10 a.m. What is the number of bacteria? 1,000 times 2 to the power of 8. So 256,000. Do you understand? Yeah, so the increasing rapidity of this bacteria is following the graph of exponential function. Understand? This is exponential function because the exponential function is in the form of y equals a to the power of x. We call this one as exponential function. Okay, let's go back to the question. So what was the size of population at 8 a.m.? What was it, students? 1,000, very good. At what time will the population first reach 1 million? 1 million, guys. So 1 million. So the number of n equals 1 million. Equals 1,000 times 2 to the power of 40. You need to solve this question. Cancel 1,000 first. So 2 to the power of 40 equals 1,000. And then I'm going to use logarithm. What log base do you want to use?
Log base 2.
Very good. Thank you so much. So put log base 2 each side, students. Okay. Then since this one is index of the value, you can move this one to the front. So 40, and then what is the value of log 2? 1. So 40 equals log 2 and 1,000. Therefore, the t equals 1 over 4 log 2 and 1,000. By using your calculator, please tell me the value of this one, guys.
About 2.4914.
2.5. Thank you so much. 2.5. So after 2.5, so what time? After 2.5 hours from 8 a.m., then what's the time, students?
10:30.
10:30, very good. Approximately 10:30. And then, what does this model predict about the size of population in the long term? What do you think, students?
It's impossible to reduce food in the population to the limit of resources.
Did you understand what William said, students? Okay. So since the function of this model is y equals 1,000 times 2 to the power of 40, exponential graph. Do you remember the shape of exponential graph? It was like this, right? Students? Yeah. So after long term is time goes by, long time, and then the number of bacteria is increasing infinitely. Students, does it make sense or not? No, I mean, the number of bacteria can be increased infinitely. Really?
No.
So, as I told you, basically the number of population can be modeled by using exponential function, but only short period of time, because let's imagine that, okay, so we all know that what is the biggest number of population in the world? Which country?
India.
India. So do you think that India population can go infinitely or no? No. No, because at some point, it's gonna be restricted by resources, the land size or the number of food, right? Do you understand? Or the stress. Because the density of the population is increasing, and then the people start to feel very, very stressed out. Yeah, the survival rate is gonna be decreasing. So it means that at some point, there is certain restriction by environment. Students, do you understand? So in a long period of time, this model cannot match. Okay, only short period of time, this model can be true. This model can give us a proper prediction, but not in a long-term period of time. Do you understand? Okay. Thank you. Okay, let's look at this key point, students. For a function of the form y equals a times e to the power of kt, the initial value means when k equals 0. When k equals 0, it means that this value is going to be 1. So it's what? It's a, right? And then as we all know that the gradient, the rate of growth, the rate of change, it means gradient. The gradient of this graph is a times k times e to the power of kt. Therefore, the the rate of growth is, this one is y, so ky, or k times a times e to the power of kt. That's just a very natural. And then example 8.5, Bianca, please read this question. Okay, student, is this a decay or growth? Decay or growth? Decay, because students, e to the power of negative 1.2t. You can draw this graph by using your calculator, and it's gonna be in this shape, And then since t means time, so you cannot read this part, please exclude this part, only this part, and it's decay, understand? I want you to identify whether this modeling means decay or growth. Do you understand? Okay, this one is decay first, and then please keep reading it. Initial mass means when t equals 0. Initial means t equals 0. Please remember the starting point, t equals 0. So when t equals 0, what is left here is just a. Can you see that? So the value of a is 72. So m equals 72 e to the power of negative 1.2t. And then find the rate means you need to calculate gradient. You need to calculate gradient. Then e to the power of kt. The gradient of this one is k times e to the power of kt. So since the value of k in this case is negative 1.2, do you understand? So negative 1.2 times e to the power of negative 1.2 t, but there is one number multiplied, which is 72. So don't forget, write 72 to the front. This one is the gradient. And then 5 seconds after. So when t equals 5, t equals 5. So substitute 5 here. And then by using your calculator, you can calculate 72 times negative 1.2 times e to the power of negative 1.2 times 5. What is it? Negative. Wasi, where is your calculator? Jason Tao, I want. You didn't take out your.
Negative 86.
Negative 86. 397. Okay, let's say negative 86.4. So it means that students, it means that around the time passes 5 seconds, the decay of this chemical substance is 86.
You got E.
Okay, so negatives. Okay, so negative 0.214.
Not just.
Okay, sorry. Time's up.
Bye, Miss Young. Goodbye,
Sorry.
What does A represent?
Initial values, initial population, initial number of bacteria, initial amount of chemical substance, etc.
Is B the final?
Wait for a sec. What is the final? Okay, students, please check the Google Classroom. Check the Google Classroom. We are gonna take number 2 quiz, the second quiz on Friday. It's gonna cover it from chapter 7 to 8.3. And also, I want you to solve this question.
Wait, is that topic longer?
Wait for a sec. Example 8.6 and 8.7, and then some of the exercise questions. I'm gonna write it on the Google Classroom. Please check it out, okay? Answer me. Thank you so much. Have a wonderful day. See you.
Please remember.
Sorry, Angus, wait for sorry.